We're here in section 3.6, and in this video we're going to look at how the chain rule can be extended to the composition of more than two functions. So our prior examples have only had a composition of two functions. There's an inside and there's an outside function, and that's it. But the truth is, in functions, we can have many different nested layers, and we can use this chain rule repeatedly on that as many times as we need to until all of the inner functions have been taken care of, essentially. So we'll look at a couple of examples here. And again, there are different methods, different approaches for this. You can use Newton notation, you can use Leibniz notation, or you can use the cover-up method. I'm going to stick to the cover-up to keep things consistent, but if you have questions on the Newton notation or Leibniz notation for these type of chain rule problems, just let me know and I'm happy to explain how that all ties together. So let's look at our first example here, where y equals -3 sine of cosine of x over 2. So there's definitely some multiple layers going on with this function. We've got -3 sine, and then inside the sine is a cosine function. Inside the cosine is, I'm going to write that as 1/2 x, just so the coefficient is a little clearer. Okay. So how we're going to do this is we are going to cover up the interior function. Okay, so let me write this here as y equals -3 sine, okay, cosine 1/2 x. Okay, because now down here we'll start doing our derivative, and I will cover up a part of that. So for our first cover up, we're going to just cover up the inside function so that there's an outside and an inside. So outside is going to be -3 sine of the inside function. So the part I'm going to cover up here is cosine of 1/2 x. So you just cover that all up, make it disappear for you for just a second. Okay. And then we're going to take the derivative of -3 sine of the purple rectangle. And so the derivative of that is going to be -3 cosine of the purple rectangle. Okay. Times the derivative of that purple rectangle. All right. Good times. Okay. And so now you would uncover that purple rectangle and see what is underneath. So see what's underneath. Let's see if I can make it happen. Oh, erased a little bit. But what's underneath is cosine of 1/2 x. And so that's what goes in for the purple rectangle in this derivative. Okay. Cosine of 1/2 x. Cosine 1/2 x. Okay. And in this first part here, the first factor, there's really not much we can do with that. We're just stuck with -3 cosine of the cosine of 1/2 x. As a little note, make sure that you notice that this is cosine of cosine, a composition, not cosine times cosine. This is not cosine squared. Okay, so just leave it how it is. Now to do the derivative of cosine of 1/2 x, notice how there's actually an inside and an outside to that function. Okay, this is our new outer function. And then this is the new inner function, okay? So we're gonna use a chain rule on this little derivative here. So we need another chain rule. All right. So I'm gonna cover up the inside of that function, okay? and we will take the derivative there. Okay. So my purple rectangle here is going to cover up the inside, and we'll take the derivative of our outer function, keeping the inside the same. So we're going to have derivative of cosine is negative sine of a purple rectangle times the derivative of a purple rectangle, because that's where the covered up portion would go. Okay, so now, just like we previously did, you're going to uncover that covered up portion and see what it was. So, boop, boop. The uncovered portion now is 1/2 x. So that's what we need to put down here, 1/2 x, 1/2 x in place of the purple rectangles. Okay. So now we have -3 cosine of the cosine of 1/2 x. That part is done. We don't touch that anymore. And now we're multiplying by negative sine of 1/2 x. And then we're multiplying by the derivative of 1/2 x, which is just 1/2. And now we've taken all the derivatives there. You might say like, oh, hey, isn't there another chain in here? Because we have 1/2 times x. But if you made that another chain, the derivative of this inside x would just be 1. So you'd be multiplying by 1. And that wouldn't really change anything. So we're done with it at this stage. That's all of our nested functions there. So all that's left is just to clean this up a little bit by putting all of our coefficients together. We've got a -3, we've got a -1 there on the sign, and we've got a 1/2. So overall that would be a positive 3/2 cosine of the cosine of, I'll switch that back to x over 2, and then sine of x over 2. Okay, and so that is the derivative of that function. Now in our next video, we'll look at another example of this.